Previous worksheets, true and proper way to do, cross that out, say integral. In some circles it's called the Newton method, although Newton would throw up upon hearing that, honestly. He thought that this is what math people made him do. Okay? The AP test, you need to understand the following things for the AP test. 1, you must approximate the area of the curve making shapes. Left, right, Riemann sums, midpoint, Riemann sums, trapezoid rules. If you shrink the shapes, what happens to your approximation? It's big. It's better, right? If you take a limit as your shapes approach 0 in width, what happens? You get the exact value of the curve. AP test expects you to be able to use the trapezoid rule, left, right, Riemann sums, and midpoint Riemann sums. That's not written on there. And now Newton to the rescue. What do you mean by Newton to the rescue? Here you go. A rock is thrown up in the air, so the position equation is negative 4.9 t squared plus 20t. What is the rock's velocity 2 seconds later? How am I going to do that, Miss B? Well, position. It's velocity from position. That's just going to be the first one, isn't it? Right? I just want to know how fast it's going. Make sense? So I want to know the rate. So let's go ahead and do that. Y of t equals negative 4.9 t squared plus 20t. Agree with this? Top to bottom, all good? 0.4 is your speed? The answer 2? Is B all good? Perfect. All right, good. And then the equation for any velocity with respect to any time t, I've already done that, right? So this is our rate equation, right? So what we did is derivative, that's first semester stuff. That's all been solid, cold. We know that, right? What are we trying to do this semester, Ms. V? We're trying to go from rate to amount. We're trying to go from speed to distance. Well, according to Newton, he said, look, if this is your velocity equation, how do you get to your position equation? Yeah. What the heck is this limiting rectangle stuff? Ew, throw up. Yes, that's the right way. Yes, that's provably the better way to do it. That said, if I can take a derivative to get from position to speed, I certainly should be able to do the backwards thing, which we're going to call an antiderivative, to get back to position. What the heck is all this limiting? Just do it backwards. Make sense? So let's do it backwards. So if I want to find position, I would do what? Now here's what I got to think. I got to start thinking backwards, right? What do we normally do? We throw the power out in front, then subtract the power by 1. So we're going to raise the power by 1 and divide by the power I get. And then raise its power by 1 and divide by the power I get. And look what we're back to. So the official Newton method, limiting rectangle method, works. It's actually the way to take an integral. That said, would you prefer to do this? Okay. Now here's something funky for you to worry about. You ready for funky to worry about? Noe's proven this works. It makes sense. You and I can both agree if I can take a derivative to get the rate, I should be able to underivatize. Or do they take the antiderivatives, what we're actually going to say this year, to get back to the amount? But notice able to prove that actually works. So this is called a theorem. It's the second fundamental theorem of calculus, so you can do this. You can't prove it. No, you're going to figure a way to prove it. How would you prove it? Area under the curve is always going to match this. How do you prove that? You can't. Nobody has so far. Somebody's got to be able to figure it out, but nobody has. Now, they've proven it for specific cases, like a billion specific cases, right? But nobody's able to prove it works every single time. Because you can't do it, right? Now, how are you going to prove it works every single time? Can't. That's dumb. That's what Newton would say. The reason why there's two people that invented calculus is Newton said, that's dumb. Who cares? And Leibniz says, no, that matters. Because we're mathematicians. If you can't prove it, it's not true. Those are two different people, two different ideas. Okay? So, what are we going to do from here? We're going to do the antiderivative. We're going to pretend like we always know it's the area of the curve, because for every expression you're going to see this year, it's already been proven. You can look it up in a book somewhere and find the actual proof. I don't care. I also don't want to go through every single time the summation equation and all the rest of the nonsense. Does that make sense? All right. So flip it over. We've now accepted the second fundamental theorem, which is what? Do the derivative backwards. It's got to be the same thing as the integral. It's always going to tell us the area of the curve. Let's do it. Chunk. So the derivative for this one is dy dx equals negative 2x to the third plus 6x. So what would y be equal to? By the way, how can you check your answers? Take the derivative, see if you get what you started with, right? If that doesn't work, you did it wrong. So raises power up by 1, divide by the power I get. Raises power up by 1, divide by the power I get. I'd bother to clean this up. All right, folks, blow through 5, 6, 7, 8. It's like Jeopardy. You have the answer. What was the question? Number 9, it's x to the 1/3 dx, right? Change it to 1/3 power because it's cube root. Raises power by 1, divide by the power you get. And then you're going to get 3/4 x to the 4/3. Boom. Make sense? Just be good? Mr. Roebuck? Good?